Okay, good afternoon everybody. So let us start our lecture today. And as you saw that from today I will take oral attendance. I will maintain an Excel sheet. You know there is 5% point for the attendance. Please do not miss attendance, okay? And then for attendance and class activities for 5% point. Okay, and according to our schedule, so this week we will start data structure. So data structure is the format. How do we organize data in your program, right? So you are familiar with some of the data structure you are familiar with. The simplest one is an array. An array is a simple data structure, linear data structure. Okay, so in an array, elements are organized one after another, all together in adjacent list. That is called an array. So that is, in general, an array is static array. So when you declare an array, you have to fix its length. You cannot change the array length while your program is running. So this is not a problem for us who we know programming. So if I have source code, then I can change my array size, right? Array length I can change in the declaration line. But mostly programs or applications are written for the novice people who do not have any knowledge about computing or programming. You can assume that, or a little knowledge. Or even if they have knowledge, we do not provide source code, actual program code to them. We provide binary version or executable version of our program or application, right? So they don't know where to change the length of the array in case they are shortest. Okay, so in order to solve this problem, there is a dynamic array. We know that array list. Okay, array list, this is a built-in data structure. Most of the languages have, like Java and C# has array list, and some other language in Python it is called list, and C++ does not have array list, but it has dynamic array that is called vector. Okay, array list, the vector is built with dynamic array with pointer. Okay, and we saw that there are other data structure like linked list. So in a linked list, data elements are organized as a link of some nodes or some elements. So for instance, in a data structure, this is called node. Each node has data and link to the next node. So if there is, this is the so data can be any data type, integer, float, double, and the built-in data type, or it can be a custom data type or an object. And link, that means if I have another node, another data elements, so this one will be linked to here. That means this one will hold the address of the next node. If there is no next node, that is the last node, that is called null pointer, null value, it doesn't contain. So in programming languages, null is just it denotes something that does not exist. So in real life, if I do not have something, how do we express that? So if you ask me, if I ask you that, show me your who does not have a computer here? Okay, if I ask you, show me your laptop, and if you tell me I don't have laptop, you tell me that you don't have laptop, okay, then how can you show something that, hey, see that I don't have any laptop? Even if you open your backpack, I will see that there is nothing over there, right? So actually in real life, nothing means nothing. But in mathematics, we show sum by something. Nothing means, for instance, I have no money in my pocket, $0, right? We express by 0 in nothing. That means nothing, 0. And in language, I said we express by a sentence. In human language, I don't have anything. I don't have that thing. But in programming languages, we denote by something that is called null. In some languages, null in uppercase. In some languages, null in lowercase also. Okay. So that means a linked list. Okay. So this is the head. Every linked list is a head, and that is tail. Tail is the last. Head is the address of the first node, and tail is the address of the last node. If there is only one node, then head pointer equal to tail pointer. If there is only one node, then that node, that is head, that is tail. If there is no node, then head equal to null and tail equal to null, right? There is nothing. If there is no node, that means, how do we say there is no node? That means head equal to null, tail equal to null, or head equal to tail equal to null. So this is how linked list is implemented in programming languages. How many of you know C++? So I think almost all of you should know, because you took data structure course, right? Here data structure course is taught with C++. The reason is that we enforce it to learn C++ language. Okay, if you know C++, how to implement data structure, a linked list in C++, then you know how pointer is used, right? Pointer is used to point the one node and connect to one node. It's a get link, get data, something, set data. Okay, so so linked list is a dynamic data structure. Then you do not need to be worried about its length. You use as much as you need. Okay, whenever you got a new data element, you link appropriately. So there is no worry about memory loss. Okay, but for the small programs, so we discuss in our class, small array, we don't have to be worried. We don't consider the array length, size, right? Because we have huge memory, gigabytes of memory, but our program is very small. But think about if you are asked to write a program to hold like ID or something, some information of all people in the USA. Then there are more than 330 million people in the USA, right? So huge numbers. And think about if the United Nations organization, they want to build a database for all people in the world. And huge data, right? So in that case, we need to really consider about memory space. Or even, for instance, in a medium-sized company, for instance, a mobile company, T-Mobile or AT&T, they have large number of users, right? Okay, so based on the purpose, there are many data structures that are built in. So we know about linked list. Okay, there is another data structure is called stack and queue, right? So these are dynamic data structures. So one of the thing is that linked list. Then the first thing is array. Okay, second thing, first one is array, second one is linked list, third one is stack, fourth one is QE. In a stack, data structure that are filled one above another or one after another. Stack is last in, first out. The element that is put and the last that is taken the first. Okay, so this is head and this is bottom or tail. Okay, and then QE is first in, first out type. So the QE that people stand for ticket. The people who comes first So maybe this is the ticket counter. People who comes first, they get ticket first. So okay, so in addition to these, like 4 data structures, right? 4 data structure: array, linked list, stack, and queue. By the way, there are built-in linked list for some languages, like I said, C++. Java is called linked array list. Maybe C# is called array list, right? Java and C# called array list, and C++ is called vector. These are built-in linked list. Okay, and there is built-in stack and built-in queue. So in addition to these, is there any data structure you remember, you recall, you think about, you know about? Who knows any other kind of data structures? Do you know any other kind of data structure you remember? In your real life, you remember something else? So you,
other variants like doubly linked list.
yes, there is a linked list. So this is why we call linked list STS plural. Singly linked list, doubly linked list. So in doubly linked list, each node know who is front of it and who is next of it. And singly linked list, it knows who is next to it, or his front of it actually. Okay, there is another data structure we should be familiar with: tree structure. So how do you think about our family tree? So I think we have a good connection with our family, right? Everybody has good connection with our family. So in a family, how we are connected? This is our grandfather, right? Maybe grandfather has some children. Okay, this is my parent. This is grandparent. This is my parent. This is my uncle 1. This is my uncle 2. And maybe I have some aunts, like 3, right? Like these are 3. And then I have some brothers. This is me, for instance. I have some other brothers, maybe sisters, and I have some cousins. They are here. Okay, I have more cousins here. I have more cousins over here. So I have nieces from here. So this is a family structure, right? Or in general, like a tree structure, right? So there are different kinds of tree. This is a regular tree or natural tree. Okay, but maybe you are familiar with one of the kind of the tree that is called binary search tree. So is binary search tree. Let us understand binary tree first. So this is a tree. Okay, so but each tree has like these are the node. Each node may have one or more children. These are the children. Okay, the node that is the root is called root level. The top level is root level, and actually it's a reverse tree. Think about other way. This will be tree, right? So this is root and then other, and these are called leaves. If there is no more child, this is called leaf node. And a binary tree, that if there is a tree that has only each node has 2 children at most. If there is a children, there any child, there maximum 2 children. There is a binary tree. This is binary tree. So this kind of trees is possible, but we are not discussing this kind of tree. So for simplicity, for instance, data, maybe we are thinking some other simple tree that is called binary tree. First of all, binary tree. So binary tree means bi means 2, right? Bi means 2. So that is organized height. So okay. So this is the binary tree. If a node has children, then there will be at most 2 children. It may not have any children. It may have 1 children or at most 2 children. Okay, so based on the number of children or based on the organization of children, trees are named with like binary tree, okay, the red black tree, and then other trees, other kind of trees, okay. Then what is that? We have other kind of trees. Okay, what do we have here? Okay, these are the binary tree, but there is another kind of tree that is called binary search tree. Binary search tree is designed based on the values of each node. Each node contain, here you see that each node contain values. It can be any kind of value. For instance, let us consider numeric data value, simple numeric data value. Okay, so then binary search tree has a speciality that the root any node, okay, any node, so has the value, okay, greater than the less than its parent root. So here if this is maybe 40, this value is 40, then this value cannot be 40. It can be equal to 40, okay, maximum, or must be less than 40. Okay, and the binary search tree means this left side, all value on the left side would be less than 40, maybe 30, and the right side must be greater than 40, so maybe 41. And this is the rule that all node has as the property that its left child never exceed the right child value, and left child must be less than, it can be equal, okay, is considered less than the parent child. So here this way, for instance, it will be 10, and this may be 20, and this may be 15, and this may be 24. So you see that the right child always greater than larger value, and left child can greater than, actually has a smaller value. So this is called binary search tree, and there are other kinds of tree. So you are familiar with binary search tree. Up to binary search tree you are familiar with in your previous courses, right? Maybe your data structure and 1322 courses, right? You are familiar with until binary search tree. Okay, so in addition to binary search tree, there are other kinds of trees. So actually in higher level programming and for data organization, so tree is widely used. Okay, so in this course it will be your goal, it will be our goal to understand tree operations. For instance, how can I get specific element from a tree? Okay, we saw that the binary search tree operation is simple because it has the property, the right is any value we are looking for is greater than this 40, then we will go to the right side. We know that the right side has the greater values. If any value we are looking for instance 30 or 27, we will compare from here, compare with this value 40. 27 is less than 40, so it will come left side, and you see that the other half, every RSI is getting half, right? So if this is binary, that means size will be, length will be log n with base 2, right? Every time it is getting half size half, right? So then we can get n log n time capacity for binary search tree operations. We'll see that. So mainly our goal will be to learn some new kind of trees, like black trees, and then let us see what do we have more also. We have one more kind of tree. This per source as function red block tree is not covered. I'll see if I can cover. Okay, so to expedite our teaching, let me singly linked list implementation example 1 Java. Okay. Just to save our time, instead of writing our code, so I want to give with some description about some my existing program. So let us start with a linked list program. Okay, so every linked list stack and queue, they are organized with node. Okay, a node can contain some data value, and each node has a link with its next node. Okay, so the next node actually it knows that who is its father or parent. So this is why data value can be any type, integer or any string type or any type, and actually the next it will be same kind node. Okay, and then it has node constructor, it creates node, take id and this. Okay, and so this is constructor, and for instance this is the display method and toString method, and this is the linked list class. And in the linked list class, actually each node has one thing, that in a linked list each node has a head. A linked list has a head denotes the first node in the linked list. So whenever any linked list is created, blank list is created, its head is null. That means a linked list is created without any data value. So this is why head equal to null. So linked list constructor, it contains generates head equal to null initialization. And we said that if head is empty, head is null, then the linked list is empty. And there are some methods, it's called prepend method. If want to add any value, so in a linked list, so we say if there are some existing node, and if we want to add a value, then there is question, where should I add new value, before this node or after this node? If we want to before, then it is called prepend operation, and if we want to add after an existing node, then we call append operation. Okay, and so for append or prepend, if your linked list is empty, there is no, if the linked list does not have any existing element, then there is no difference between prepend and append. That means this one, if head equal to null, then head equal to new node, and in the new node getting value id and name, and then it returns. That means if the linked list is empty. And same thing here also, if the linked list is empty, then there is no difference between append and prepend. So that will be the only one element, right? Initially the linked list is empty and you are putting the value, that will be first value. that will be head. Okay, and the question will arrive after this if it is not null, if it is not empty. That means if the linked list is not empty, right, then the question is whether it will go before this or after this. Before is called prepend. Okay, for prepend we need to create a new head, right? For instance, here, give attention please. If you understand these two small methods, then you will understand half of linked list operation. And linked list is the foundation or base of linked list, QE, and other advanced data type like tree. Okay, so we need to give attention over here, please. And if you don't understand, please let me know. So, for instance, let us see that this block is same. This block is same for append and prepend method. That means if empty, linked list is empty, the ls ll linked list is empty. Okay, if it is not empty, for instance, we have already one node over here. Okay, we have already an existing node set, so that means it has already head. So for instance, if it's a node, already node, this it has a head, because every linked list has a head, right? We saw that, and the initially head was null, but whenever we insert a value, then head becomes the node. You see the head is initialized. So once it has a value, then it must be it has a head, right? And if you want to add a new node before this, then what do we need to change? We need to change the head, right? The new head should be from here to there, right? First of all, we need to change the head, because every linked list has a head. So then how do we change that? We say the node head is head type is node, new head equal to whatever you are putting new head, and then you are putting that value on the head. For instance, this is the head node denoting, okay, and you are putting that value. And then what do we need to do? Okay, we need, there was a head was initially it was assigning here, right? Okay, that means you say new node, this is our new node, right? New node dot next equal to head. So that new node dot next, actually next means, so actually this is like in the book, and then the description in the books has arrow like this. Okay, so it is like this. So be considered with this head. So it said new node, this is my new node dot next, because every node has next element equal to head. So we are putting this one head initially over here, we are putting this head here. So then that will be our first node. Head is the first node, right? Okay, and so head will be, so actually we are new node dot next equal to head. If you use setter, so you see that one, you setter, then is there, and head equal to new head, and then do these two lines, and head equal to, so this will be, and this will be your head. So this will be your head. Whatever you are doing over here, new node dot next equal to head, you are assigning, you are making this link, first one by the first statement, and the second statement you are assigning head from here to here. head equal to new node. So we already have a head, right? So look at over here. So in the new node linked list has a head. There is an existing head, right? There is a value for the head. There is an existing value for the head. So you are putting that value, okay? So initially the head for the first node, for the blank node, head was empty. If there is one node, then you see head contains a value over here, and you are putting that value to the new node dot next. So you are making this the next one, and then you are making head as this in the new node. You are making, so new node with the new value, new node with new value will be your head, changing the head. Okay, in this way it is called prepend operation. It is adding the top above. And in case we need to add in the bottom, in the behind, okay, so that this is the empty, this is same. Actually what do we need to do? So we are saving, we are making another current node. This is the current node we are making, and then we are saving our head to that value, temporary. This is a temporary value, temporary position. We are saving current node, okay, head value to our current node. For instance, we have our head value here, okay, we are saving that into a current node. So then what will go, we don't know how many existing elements are there. How do we pass in a linked list? We go one by one step by one step. This is a restricted stairway that you cannot bypass on stair. You have to step on every stair. Okay, linked list is a restricted stairway. So here, while current node dot next not equal to null, okay, that means this one is, if this one is the current node, okay, dot next equal to null. That means, so while I am not going to the last, this is, that means while I am not going to the last node, where I am going is here, current node equal to current node dot next. This line is stepping on the stairway, going one by one, one by one, one by one. Okay, the goal will be go to the last node. Here we started with an example with one node, so visually we see that there is one node. So the question will be, why do I need to do this? I see that only one line, but for the unvisual things, we don't know how many existing nodes are there. We don't need to know. Okay, so this way, for doing this for loop, we will go all the way end. Okay, and at the end we will make our put our current node. Okay, and there is one more line. So yeah, I was missing. And this is the last line, is that current dot node dot next. Whenever you are going to all the way end, okay, then you are making another node over here. This is the node. So current node dot next equal to new node, and in this new node you are putting your data. So these statements are just stepping on the linked list. So the purpose of this statement is to go all the way into the linked list. Okay, after you go all the way into the linked list, you are putting your data, current node dot next equal to new node. Now let us see let us compare you see that compare the statements, two statements over here. So compare these statements. Just forget about the name. Whatever name I gave, this is any name you can give, right? So new node or whatever you said node. So how these are organized? So this one, how this new node is put. So new node is put and the beginning for prepend operation at the beginning, and for the append operation, new node are put all the way in. Append means later. Okay. So if you understand this append and prepend operation, there are other operations. For instance, remove first node, remove last node, display all nodes, find node by ID, find node by name. Okay, these are the other operations that if you understand the append and prepend method, you will be able to understand this easily. So I'm going to share this program with you. Where can I share it? Teams. Okay, please save this program in your account. Okay, just make a fork and then linked list.
Yeah, I have a random question about that. If we were to have linked, just like the URL for like our assignment for our homework, does that have work too? Because I put both. I put like the text and the.
That's good. I will click on the link first.
It's easier to read it.
Yeah, it's easy for me too.
Yeah.
Okay. So if you go my program, for instance, any program if you get, for instance, I have this program. Last one is Java, and the same name. If you C#, I should have another program with C#. Okay. Just the last word Java or C#. This is why I name my programs. So you can find this one with C#. If you need this C#. Okay, and then stack. Stack implementation example 1. This is C#. So in stack there are two methods. One is called mainly two methods, push and pop, and there is another thing is called pick. Pick just grab the top element. It does not delete, does not remove. Okay, so is the pick is the correct word or pick versus pick. Pick is something I look at. Pick can be create. Folder name. Okay, so this one C# program, and there is one also. If you change instead of C#, example 1 to Java, then I have another program with Java, same program with Java. Okay, so if you understand the node class, you see the node class is same for linked list, stack and QE, and then for stack operation mainly it has top node, it has node has top property, and pick operation and push operation and pop operation. Okay, so please at least go through these programs, okay, quickly. Stack, okay, stack Java, and then I have QE, QE implementation example 1 Java. So QE has two operations, enqueue and dequeue operation. Enqueue means entering an element. So you see that for node is same node for all three, linked list, stack and QE. Okay, so for QE it has head and tail. Okay, for an empty QE, head and tail equal to same, head equal to tail equal to null. Okay, and then it has pick and it has bottom, and you can do enqueue operation, maybe inserting a data in the top, and dequeue operation, that means removing a node from a QE. So this is the program, and then C# is this one, and Java is this one, and I have C#. Okay, and it has enqueue and dequeue operations, and if you run this program, all of this will work. Just get this program and fork it in your account. Okay, so Alice, you are not here in last lectures, right? Do you have a Replit account? Yeah. Okay, so please fork my program in your Replit account. Okay, forking means save my program. Even if I delete my program, it will still, you will have a copy. Okay, then our another data structure is called BST. It's called binary search tree. Do we have BST? Okay. BST implementation C#. So you see the same node is pretty little bit different. So in a binary search tree, each node has left and right. Okay, left children and right children. So I have these methods for BS3, and then you will okay. So so in a BST, binary search tree, okay, So this is the binary search tree. This is the 40 in the top node, and then 20, and then 60, and then 10, and then 30, and then 50, and then 70. Okay. First of all, let us check that whether it is a BST or not. The two properties up to in order to be a BST. Okay, one of these is first of is that each node has 2 children maximum, no more, not more than 2. Okay, so these are the leaf level, they don't have any child. So but except the leaf level, all other levels have 2 nodes, exactly 2 nodes. Okay, binary for binary tree. And then search means, binary search tree means we can search in binary order. So that means you see that 40, the left, this we can say this one is the left branch, and we can say this one is a right branch. So in the left branch is a left subtree, and we can say it's a right subtree. So one thing is that all values in the left subtree are less than the parent value, right? All values on the right subtree are greater than the parent value. Okay, and you can make another subtree this way, another subtree this way, and for every subtree this property exists. All values in the left subtree is less than the parent, and all the right subtree is greater than the parent. Okay, then there are 3 common operations. It's called traverse operation, BST, traversal operations. There are 3 operations. One is called Inorder, something,
Inorder, preorder,
and postorder. Exactly, thank you.
I remember in 1522.
Yes.
Okay.
So one of those called Inorder, another is called preorder, another is called postorder. So if you understand this term, order of what, if you ask me order of what, then it's easy for you to remember. Order by what? Order by what? Order by parent. Okay. So based on the parent position. Okay, parent position. You see that this is the, if we, for the entire BST, this is the parent, right? 40 is the parent, right? For the left subtree, 20 is the parent, right? For the right subtree, 60 is the parent. So every tree or subtree has a parent, right? So this one is the root level except the leaf level. So leaf level itself is parent. All leaves are itself parents, right? By default. Okay. So here, based on the position of the parent root, traversal is classified into 3 types. First one, Inorder. Inorder means your, let us go to preorder first. Okay, let us understand preorder first. Preorder means your root will go first. Your father will go first. Okay, that means we will start from the top. This is the top father, right? Top. Then we will come to the left subtree. Then in the left subtree, who is top? 20, right? Then come 40, 20. Again we will come left side. What is the top? 10.
Can't you like use a recursive method to
preorder the.
We do. We use
like
recursive
if
method.
you like build the tree data structure.
Yes.
then
So
use
in the
recursive
program,
method.
if you go to the program, you will see that it's recursive.
Yeah.
Okay. Thank you for remembering. You can't use, just I'm giving you a heads up so that you can remember all of this. So if you forget, please by this week, before next class, just look at my programs. Okay, all together. Then so 4D. So all for the pre-order root will come first, right? Then 4D, 20, 10. Then from 20, this will go this side. 3, 30, right? After that, this branch is done, then it will go to the right side. The right side, it gets top 60, right? Then it is 60. Then it will come left side, 50. Then it will come, it will go to the right side, 70. So now we got 40, 20, 40, 20, 10, 30. Okay. 60, 50, 70. You see that? 40, 20, 10, 30, 60, 50, 70. This is called pre-order. For the post order, okay, post order, that means parent will go last. Then if parent will go last, where do we start in? We skip the parent. We start from here, but we'll skip this. Then we'll go left children, we'll skip it. This is parent. Then we'll come here, there is no more child, so we will start from here. Okay. Then 10, then we skip the parent is last, right? Then 10, skip the parent, go to right. Then 10, 30, 20. We are done this side, right? Okay. Then parent, we will skip parent. Then we will go right side. We will skip parent. Then 50. Then we will skip point parent, then 70. Then we will come here parent 60, and then we will come to the greatest parent, then 40. So if you hear 10, 30, 50, 70, 60, this will be 60, 60, 40. This is 60. Okay. Does anyone has any question about this? These are known stuffs, right? So this is I'm going quickly. And the last one is in order. In order means your parent will be inside, in between its children. Okay. So we are coming here. No, we cannot take the parent first. So we'll go left tree. We cannot take first. Then we'll go 10, then parent, left 10, then 20, 30. Then parent in the middle, 40, and then 50, 60, 70. Okay. So you see that the in order traversal, it also does another thing. What is that one? It also does another operation. What is that? Sorting, right? An ascending order, sorting ascending order, right? So in order traversal also does a sorting operation in a BST. Understand? This is a quiz question or interview question. Okay. So if you want to do a sorting operation using a BST, what kind of traversal you will do? In order, right? Okay. So maybe I will give you this program to you. Again, I'm giving you this program. Please save it in your account, and then please spend some time to recap this.
Why would we need to save it in our account if it's available on your account?
Sorry?
And why would we need to save it if you have it on your account?
If I delete it from my
When you
account,
delete stuff?
yeah, if I change it,
Okay.
still you have a copy.
Okay.
So I have this one in Java.
Do you like delete a lot of your stuff?
Sometime I change. You don't know, or even I don't know when I will make change. If I find something mistake, okay.
Well, if there's a mistake, then wouldn't there also be mistake on
So
ours? and we
if
wanna
you
update it?
understand, then you will see that if you understand, then you will find mistake. And then if you find any mistake, please let me know.
Okay. Well,
Okay.
that's good if we find mistake, because then
Yeah.
we understand the program.
Does anyone has any question? Okay, the announcement is that your test will be next week this time. So not this time actually, at 2 p.m. right? During your class time, it will be in class on paper. Bring your pencil and eraser. Okay, it will be open book, open note, open printed materials, but closed device. Okay, you can bring your entire book. As many books as you need, you can bring. You need to study, because if you have books, even if you do not study, you will be out of time by looking where is there. Okay, but if you study, then you will quickly remember that, oh, here is that point is
Was
on
on
that.
Thursday or?
Tuesday, 28,
So
right?
week from now?
I made an announcement in D2L, and did you see? Did you see that I made an announcement and I uploaded a study guide. This one, the study guide. Did you see this one? Okay, please follow the study guide. Okay, I will follow that for the test. Okay, for this code, we are sorry that we do not have any GTA because it is an assistant, but maybe you are welcome to see me during my office hour, or you can get appointment with me, or you can go tutoring center. They may help you, or in the Google knows everything, right? Google is a wizard. Google is a wizard. You can do Google search to find a lot of things, right? Lot of items. Okay, sorry, one thing that I forgot, I forgot to open the book. So the book today we cover book chapter maybe 10. Book chapter 10. Okay, actually I covered quickly because I do have programs. Okay, but please spend some time and then your task is that since it's an algorithm analysis course, so please read the book and find out the time complexity of each of the functions in linked list, stack, and queue. Okay, so if you read the book, you will get quickly what is the for each operations, what is the time complexity. You will get some quiz questions from that kind of quiz questions. Okay, and also from your test questions you may have some true false questions for that kind. Okay, so please don't forget to read sometime the book. Okay, and then does anyone has any question? Yes, we don't have a class. In case I do not have a class, then I will make an announcement. Okay, the